Hello, welcome to the second step of adding line sensing to our Wizibot. This is step number 2 of 5 steps. If you have not done step 1 yet, please go back and make sure you do step 1 first. We're going to be adding to the code that we wrote in step 1 in step 2, so you're going to have to do that first. Okay, so go back and do that. In this step, we're going to be adding in the ability to actually sense the lines underneath the line sensor. Okay, I'm going to also introduce the hash define command. So the first thing I want to introduce is this hash define command. This is an alternative way to declare our pin numbers for our Arduino. Okay, this is what we call a pre-compiler command. You've seen the hash before. We used it for the hash include for libraries. Okay, what this effectively does is before it compiles, so when we hit that little verify button, it runs what's called a pre-compiler. A pre-compiler effectively goes in and modifies our code file. Okay, in the case of the hash include, it goes off and grabs some code from elsewhere and kind of copies it into our code file. Okay, so before it even compiles, it copies all that code in and then actually compiles with all the code from the library and the code that we typed as one file. Now the hash define command is a different pre-compiler command. This is effectively a find and replace command. Okay, so we say hash define. We have a name, in this case it's going to be button pin in the left there, and then we give it a number or a value. In this case we're going to say 12. Now hash define is a pre-compiler, so that's going to get removed before the program is compiled. Okay, and what's going to happen when we hit that verify or compile button, it's going to go into the pre-compiler and it's going to basically do a replace, and it's going to replace button underscore pin with the number 12. So if you look after the pre-compiler box there, you will see that the new code file that is generated has removed the hash define. Okay, it's removed button underscore pin and it's replaced wherever button underscore pin was with the number 12. It then passes that new document that it's modified into the compiler. Now there are technical reasons why we would use either this hash define or the integer one that we've used before. So in the past we've always said things like int button underscore pin equals 12. Okay, now int is a declaration of a variable type. It actually occupies some memory on the Arduino. It's not a lot of memory. It's going to be about 2 or 4 bytes depending upon the Arduino. Okay, and our Arduinos generally have enough memory for what we do. However, if you're doing very complex programs, if you've not got a lot of memory to work with, you actually start to run out of memory eventually. Okay, and so to save memory, what you can actually do is, like I say, this pre-compiler command. Effectively, instead of compiling into the code and using up memory, we simply do a find and replace before we compile the code. Now the advantage of this is obviously it uses less memory because it's not occupying memory on the Arduino, it's just built directly into the code. The disadvantage is you could never ever swap that pin number after the pre-compile. Okay, so if you had code, for example, if you had a configuration for a technician or something where they could actually swap which button does which functionality. So let's say they've got 2 buttons on there, one on button 12 and one on button 13. Okay, and they want the ability to swap the pin number. Okay, you would not be able to do that with the pre-compiler hash define because the hash define has hard coded it to 12. Okay, if you stick it in a variable that's in memory on the Arduino, it's in memory while it runs. You can then swap the value inside of that variable, so you could swap it to a 13, and then button pin is now going off pin number 13. Again, in many ways, it's not going to have much impact on what you lot are going to do. Okay, and the reason why is because you're not going to get into the complications of that. However, when you go onto your sort of YouTube or Google and you look up different tutorials, they may use this hash define or they may use the integer method. Okay, they're both pretty much the same for what you're doing. Okay, don't get too worried about it. You just have to do one of them, either hash define or it's int button pin. Okay, so now that we've gone through the define command, let's actually add the code for our line sensing to our Wizibot. First thing that I want you to do is I want you to load up your code from last step. Okay, so that's when we added the EEPROM stuff. What we're actually going to do is we're going to ensure that we always have a backup of the previous session so that we can always come back, restore that backup, and then resume should we make any mistakes. Okay, so what I want you to do is go to Arduino, go to File, Save As, and then just save it as a new name. Okay, so it's probably going to be something like step 2 line sensing or something like that. Okay, just give it a different name. Now what you will also notice when we do a save as is the Arduino not only copies the main code file, it also copies any tabs that are part of that project. So it will save as on all the little tabs as well. Once you have done that, I want you to ensure that it has actually made a save backup. Okay, so one of the things, if you're on the lab PCs, okay, it will not remember that code file if you put it on, say, the desktop or in the downloads folder. Okay, so what you need to ensure you do is that either, if possible, bring in your own laptop. It's the safest way to do it because obviously you know where all your files are. Okay, otherwise save it to your student drive and then check after you've done the save as to ensure that it has actually created it on the student drive. I think we've had a few issues with the student drives recently, and I'm not entirely sure why that is, but just check it has saved it. If you still have issues after that, you can email the code to yourself just to make sure that you've got a backup on your inbox. Okay, or if you have a memory stick or hard disk, just save it to that. Okay, so just make sure it's definitely saving, because I think we have had a few issues over the past few weeks with the lab PCs. It's your own laptop, obviously it's your laptop. I'm sure you know how to use your laptop. Once you've done that, once we have this new Arduino sketch ready to go, I want you to create a new tab and call it line sensing. So if you go into Arduino Studio, you click on those three little dots that are below the serial monitor on the right hand side of the window and click on New Tab. In the dialog that pops up, I want you to type in line sensors and hit OK. A new tab will appear in Arduino. Once that new tab opens, I want you to type in the following code. Pause the video, type in this code, and then resume the video and I'll explain what this code does. So in this code that we have now just typed in, we have two functions. We've got the void initialize line sensors, which is going to initialize our line sensors. And then we have the bool sensor can see line. And then it passes in two parameters, a sensor pin and a baseline. I'll explain that in a second. First up, let's have a look at that initialize line sensors. The first thing we're doing in the initialize line sensors is we simply set up the pin modes for the left and right sensors. They're on pins A0 and A1. Okay, we're going to set them to input because we're going to be reading in those inputs. The next thing that we're going to do, we don't actually know what the reflectance is of the desk underneath the robot at the start. Okay, so we actually need to take a reading. We could, if we wanted to, hard code this in. So we could just assume that it's going to be a certain reflectance. But one of the best things we can actually do is have the robot detect it itself. So the first thing we do is we're doing an analog read on the left sensor and an analog read on the right sensor. Okay, and that gets a reflectance off the current desk. We're going to store them in little variables, and it's going to remember that on the Arduino for the duration of the program. We're going to store that in the left sensor baseline and the right sensor baseline. These are, like I say, our baseline readings for that reflectance that's coming off a standard desk. It's important when we initialize that we don't have the robot sensors above the black tape line, okay? Because otherwise that we use that as the baseline and it won't work. So we need the baseline of the desk without the tape. Once we've initialized our sensors, what we are going to do then is in our loop function, we're going to constantly check to see if we can see the line under the sensors. And to do that, we're going to call the second function here. We've got bool sensor can see line. Okay. Now we're going to use this function twice. We're going to use the function first for the left sensor, and then we're going to use it again for the second right sensor. Now this function is going to return true if it can see the line, or false if it can't see the line. And in order to work for the left sensor and the right sensor, we're going to pass in two values into the function. The first value is going to be the sensor pin. So that's either going to be the left sensor pin or the right sensor pin. We will then pass in the baseline for the sensor, which is either the left sensor baseline or the right sensor baseline. I'll explain that more when we get to the loop function, and you'll see how we're going to call this function. Okay, but we can pass those values in so that we can use the same function twice, once for the left sensor and once for the right sensor. The first thing that we're going to do in this actual function itself is we're going to take a sensor reading. We're going to read off the analog, the sensor pin, and we're going to take that reading. That is the current reflectance that's coming off the desk at the time of calling this function. What we then need to do is we need to work out by what proportion does the reflectance need to drop in order for it to detect a line. So we're going to calculate what we call a new line threshold. We're going to use the baseline that we captured at the start of the robot, okay, which was the baseline reflectance of the desk. And then we're going to actually take 90% of that. So we're going to multiply it by 0.9. This gives us 90% of that baseline reflectance. Anything below 90% will then count towards that line. Okay, so if that reflectance has dropped by over 10% or 10% or more, then that will actually return true to say it has seen the line. If we ever need to modify this, if you're having issues, let's say that's just not enough, you can always modify that 0.9 to change the percentage drop that is required. If you wanted to detect a 20% drop, you would change that to 0.8 because that would be 80% of the baseline, which is a 20% drop. Okay. Now, if that sensor reading that we've currently just taken is now less than that 0.9 of the baseline, then it's going to return true to say it has seen the line. Otherwise, it's going to return false. So if it doesn't return true, at the end of that function, it will return false. Now that we've typed in that code, I want you to go to the main tab again. This is where our main code belongs. And I want you to modify that main tab. Make the following changes and then resume the video. Now that you've made those changes, let's go through what we have just changed. The first thing that we've done is we've defined our left sensor and right sensor pins. Okay, our left sensor is going to be plugged into socket A0 and our right sensor is going to be plugged into A1. If you have the sensors plugged in the other way around, you can do one of two things. You can either swap the wires over, okay, on your Wizibot, so the actual physical wires themselves, so that the left sensor goes into A0 and the right sensor goes into A1, or you can modify the code here and just swap your A0 and your A1 around so that your left sensor becomes A1 and your right sensor becomes A0. Just check you've got it the right way around, otherwise the code is going to detect it incorrectly on those sensors. Next thing that we then do, we actually declare the variables for our sensor baselines that we took in our initialize function. Okay, so this is going to happen before we initialize our sensors in the code compiler. Now we have our little bits of memory where we can store those baselines. We go into our setup function, and then after load configuration from the EEPROM, we're going to then initialize the line sensors. So that's going to call that initialize line sensors that we typed into the line sensors tab. That's going to go off, it's going to set up the pins, and it's going to grab those baseline sensor values and store those in those variables. In the main loop function, we now added the code to actually see if we can see the lines. We're going to make two calls. Okay, the first call we're going to make is to sensor can see line. Okay, we're going to pass in the left sensor pin along with the left sensor baseline. So that function now has the left sensor pin and the baseline for the left sensor. It's going to run those calculations that we had in the line sensors tab, and it's going to return if it can see the line. So if there's been a 10% or more drop on the reflectance sensor on the left sensor, or it's then going to go into the else statement on there, and it's going to say sensor can see line, but now we're going to pass in the right sensor details. So we're going to pass in the right sensor pin and the right sensor baseline. So that same function is doing it for the left sensor and the right sensor. We're just passing in the pin number for the sensor and the baseline for the sensor. If that right sensor can see the line, then it will actually say right sensor can see the line. Okay, otherwise it's actually not going to print anything to the serial monitor. If you want to print something to the serial monitor just to say it can't see the line, by all means type serial.println in the else statement there, just to say can't see line. I've left it out there just because it ends up spamming the serial monitor. Okay, so it's better just to show when it can see the line as opposed to when it can't see the line, or at least in my opinion. By all means, make that modification. Now, once you've got this code, upload the code to your Arduinos and run it. Okay, what you should see is that when you take, say, a piece of black tape, or if we've got some black heat shrink, I'll probably cut a few pieces off for you. When you pass those underneath the sensor, you should see on the serial monitor that it says that the left sensor or the right sensor sees the line. Okay, if it is indicating the wrong sensor, then check your socket. Okay, make sure your sockets are the right way around. And if it is not sensing it at all, then come and find me and we'll have a look at what's going on. It could be a sensor fault, or we may actually just have to modify that percentage drop that we're detecting for your sensor. Okay, it should work for the most part. We should be seeing a drop of around about 30 or 40% when you pass that line underneath the sensor. Okay, once you've done that, you can then move on to step 3 video. Like I say, if you have any issues at all, find me in the session and we'll have a look and try to isolate what the problem is.